In this next lecture, we'll look at the graphs of exponentials. We know it's this J-curve, but kind of dissecting what we had earlier, this form y equals a times b to the x. We want to dissect that and remember that a is my start value. So in this first graph, my start value is 3. So I'm going to go up to 3 on my y-intercept, and this is my growth. That means I keep 100% and I put in 20% additional to that, and so we know we have a J-curve that's heading up. How steep is it? Well, the steepness I would get out of a calculator. The 1.2 or 1 and 20% shows me that's growing by 20%. Pretty good growth. Let's go ahead and look at the next equation. We'll graph this in red. Again, I need to have it of the form y equals a times b to the x. I see my b is 1.6. In other words, now I'm growing by 60%. But what's my a value? I have to know where to start. A lot of people want to start at 0. Well, what's 0 times 1.6? It's 0. I will never go anywhere. So if you recall, we could have a slip of 1 in there. 1 times anything in it is itself. So if you don't see a start value, just slip that 1 in there. Now this function actually grows faster because it's adding 60% every time. So just to show that here, it's going to ride along this axis and then it's going to take off and surpass the blue because it is rising faster. But notice it takes a little bit because my start value is lower. Let's look at decay. Again, looking at the first graph, I'll graph it in blue. It has a start value of 3. And let's see, it's decaying. It's not decaying by 80%. It's decaying by 20%. 1 minus 20% is my 80%. This is the rate of decay. What's in there is what I keep, what I have. So I keep 80%. I'm losing 20%. So again, I'll pass through here. It's fairly steep, but I'm coming down this way. And there's my start value. And you might wonder, why is that your start value? Well, because this is an exponential, if I put in x to be 0, anything to the 0 power is 1. Mistake would be to say it's 0. Anything to the 0 power is 1. 3 times 1 is 3. That's why this position, the A, is my start value. Now let's go ahead and look at the next one. We'll graph this one in red. Again, it has a start value of 3. But this says, you know what? We're going to keep 30%. So what's my rate of decay? 70%. So I am decaying faster, meaning if I'm only keeping 30, I get smaller and smaller and smaller, and I come down here. Now notice, in both of these directions, we have a horizontal asymptote. Whether it's decay or growth, it looks to me like this axis is my horizontal asymptote for both of them. So we're going to do a little calculus here, and if you recall from rationals, I'm going to look as x gets very large, and I'm going to do this with the decay graph. If I look above here and look at decay as x gets large, my decay graph as x gets large is coming down into this axis, and so it's coming down into 0. Y is equal to 0 when x is a super large number. When I approach negative infinity for my growth, that's heading this way, and again, as you notice, my graph is headed towards 0. Therefore, y equals 0 is going to be a horizontal asymptote, meaning I never get there. Why can I never get there? What's the reason behind that? Well, when we start to look at exponentials, can you give me a power on 2, my factor, that's going to produce 0? Well, you might say negative 1. Well, that's 1/2. If you say negative 2, that's 1/4. Notice this is decay. The power there, that negative power, is flipping it over. It will never get to 0. There is no power on any factor that will make 0. So let's look at our domain and range for both of these. The graph extends left and right. Remember your formal notation. I can't include infinity either side, so I put parentheses. My range is my y. X was domain, range is y. So the lowest I go is 0. The highest I go is to infinity. But remember, I never get to 0. So we're going to call that infinity, and we're going to have parentheses around both of those. So the next lecture, we'll look at how do I transform these graphs. In other words, how do I take this U situation and shift it to the left, right, up, down, just as we've done with parabolas, cubics, rationals, and so forth.